All right, we have one section left for our factoring rules. The last one that we're going to look at is factoring special forms. This comes from section 5.6 of the book. We're going to look at two special forms. The first one is going to be a perfect square trinomial. And so basically, this is going to have three terms. We have two different versions of this. The first one is the first term squared plus 2 times a times b plus b squared. This is going to factor to a plus b squared. The other one is if the middle sign is negative, a squared minus 2ab plus b squared factors to a minus b squared. Now, as these are trinomials, you can also use our basic rules for factoring trinomials in order to do these. But if you can recognize it as a perfect square trinomial, then it makes it a little bit easier. So let's go ahead and look at some examples. Example A, we have x squared plus 10x plus 25. So I'm going to go ahead and just factor this like normal. In order to multiply to x squared, you have to be x and x. Things that multiply to 25, again, since this is a perfect square trinomial, I want something times itself, so I want 5 and 5. And again, our rules still apply. In order to multiply to positive 25, we have same signs, and both are positive. So you can write it like this, or you can go ahead and write it using exponents. We get x plus 5 squared. All right, let's look at example B. Now, example B, this is one where if you can recognize it as a perfect square trinomial, it makes your life a whole lot easier. Here we have 16 and y squared, those are both perfect squares. 49 is a square, and so I'm going to go ahead and factor this using my rule for a perfect square trinomial. So 16y squared, something times itself, this is going to be 4y and 4y. 49, we should get 7 and 7. And now we do have same signs. Both are negative. Again, you can write this using exponents. So we can write this as 4y minus 7 squared. All right, a couple more. Let's look at example C. Now, the first thing that I notice on this is 20 is not a square. Neither is 125. So why is it in this section? Well, the first thing we should note, as always, is do we have any common factors? All of these numbers here are divisible by 5. So let's go ahead and divide. Let's go ahead and factor out the 5 to start off with. So if we factor out a 5, 20 divided by 5 is 4. We keep our x squared. 100 divided by 5 is 20. We keep our x. And 125 divided by 5 is 25. Now if we look at our inside thing, notice that this first term, this is a perfect square. 25 is a perfect square. So this is now a perfect square trinomial. So I'm going to keep my 5. What times itself equals 4x squared? We should get 2x and 2x. And what times itself gives us 25? We should get 5 and 5. And again, we have same signs, and both are positive. Again, you can write this with exponents, so I can write this as 5 times 2x plus 5 squared. All right, last one. For this one, don't get so worried about the 6's and the 3's. We're just going to go ahead and factor it. We don't have any common factors, so we want to go ahead and just do our regular factorings. So 25, what multiplies to 25? We get 5 and 5. A to the 6th, if I break that into two things that are the same, we're going to want a cubed and a cubed. 3 plus 3 adds up to 6, and they are the same. My 9 is going to be 3 and 3, and just like with my a's, b to the 6th, this is going to be b cubed and b cubed. Again, we have same signs, and both are negatives. If you want to write this using exponents, we get 5a cubed minus 3b cubed squared. All right, that takes care of our perfect square trinomial. The second one that we want to look at is difference of squares. And this is really easy to recognize when we talk about factoring. It is one of the only ones that we have that has two terms. So our rule is a squared minus b squared. Notice there is no middle term. This means that I want to factor my first term, which is going to be a times a. My b squared factors to b and b, and we have different signs. So let's go ahead and look at some examples. Example A. My firsts, in order to multiply to x squared, I want x and x. My lasts, just like with my perfect square trinomial, I want something times itself that multiplies to 9. That's going to be 3 and 3. Now the main difference is that we have different signs. So we get x minus 3 times x plus 3. All right, for example B, and sorry, I didn't realize this was going to be exactly the same. The first thing that I want to do is I want to put this in descending order. So I'm going to rewrite this as x squared minus 9. From here, we can go ahead and factor. X squared is x and x. 9 is 3 and 3. And we have different signs. The main reason that I wanted to write this in descending order is my first term is negative, and so you can either factor out the negative or you can rewrite it so that it's at the end. All right, let's go ahead and look at a couple more. Example C. I notice that these two terms are both squares. So 25y to the 6th, how does this factor? Well, 25 is 5 and 5. Y to the 6th, if we split that in half, that's going to be y cubed and y cubed. 49 is going to be 7 and 7. X squared is going to be x and x. And then we have different signs. All right, let's go to example D. Okay, for example D, there's two things that you can do here. The first thing, I'm going to go ahead and just leave it in the form that it's in. The first thing I want to do is I do want to factor out a 5. And if I factor out a 5, I am left with 1 minus x squared y to the 6th. Now this is difference of squares. 1 is a square, x squared is a square, and y to the 6th is a square. So we can go ahead and do difference of squares. I'm going to bring down my 5. Something times itself that multiplies to 1 is just 1 and 1. X squared breaks down to x and x. And y to the 6th breaks down to y cubed and y cubed. And then we have our different signs. Now the other thing that you can do here is if you want to write it in descending order, the first thing I'm going to do is just rewrite my terms. So I get negative 5x squared y to the 6th plus 5. And if you're going to do this, instead of factoring out just a 5, we want to factor out a negative 5. So we get x squared y to the 6th. And 5 divided by negative 5 is minus 1. We still get difference of squares, so I'm going to bring down my negative 5. And if we factor this, we get x and x, y cubed and y cubed. 1 is still 1 and 1, and we still get our plus and minus, or our minus and our plus. So that's two different ways that you can handle this, and either one of them would be considered correct. This one, you do not have to write in descending order if you don't want to, mostly because this first term, since it's positive, it's not going to be all that difficult in order to factor it. All right. Let's go ahead and try some more complicated problems. Now we haven't mentioned anything about four-term things in this section, but remember that whenever we see four terms, our first thought should be factor by grouping. So if we go ahead and do factor by grouping, in the first set, I can factor out an x squared. I am left with x plus 3. In the last set, I can factor out a minus 4. And if we divide each term by minus 4, we get positive x and positive 3. From there, we're going to go ahead and factor out an x plus 3 from each thing. The first set, if I factor out the x plus 3, I am left with x squared. In the second set, if I factor out x plus 3, I am left with minus 4. This is as far as we've gotten so far, but now one of the things to notice is x squared minus 4 is a difference of squares. So I can continue now. I'm going to bring down my x plus 3. x squared, this is going to be x and x. 4 is going to be 2 and 2. And we have different signs. It doesn't matter where you put them. This is now considered completely factored. All right, let's try one more. Example B. One of the first things I notice about this is both terms have a y. So I'm going to start by factoring that out. If we get rid of y from each term, I get 16x to the 4th minus 81. All right, the thing inside parentheses, this is a difference of squares. So if we go ahead and factor this, 16 is 4 and 4. X to the 4th, if I break that down, that's going to be x squared and x squared. 81 is 9 and 9. And we have different signs. So now my question is this completely factored? The answer is no. 4x squared minus 9, this is difference of squares. It does factor further. Now, one thing I do want to point out is sum of squares. Have we talked about this in terms of factoring? We have not, and the reason we haven't is because it does not factor further. Sum of squares, if there is a plus sign and no middle term, then this does not factor any further. There is nothing that is going to have same signs and cancel the middle term. So just like with our y, we're going to bring down the 4x squared plus 9. Now 4x squared minus 9, this is difference of squares, and this does factor further. So 4 is 2 times 2. X squared is x and x. 9 is 3 and 3. And we have different signs. This is now considered completely factored. All right, the last thing we want to look at is solving some equations. So let's go ahead and see what we can do. Remember that the first thing when we solve equations is we need everything on one side. So for instance, example A, the first thing I want to do is I want to subtract 20x. And I want to rearrange this so that this is in descending order. So I want it to be x squared minus 20x plus 100 equals 0. From there we can factor. X squared is x and x. 100 is 10 and 10. We have same signs and both are negative. Now from this point, we want to set each factor equal to 0, but one thing on this is, do we need to set them both equal to 0? And the answer is no, because they're the same. So I only have to work with one of the factors. X minus 10 equals 0. From there we can add 10 to both sides. And we get x equals 10 for our answer. This particular problem only has one solution. All right, let's try a couple more. Let's come over to B. First thing I notice about this is that we have a common factor of 2. If we factor out the 2, I am left with x squared plus 6x plus 9. I can factor this further. X squared is x and x. 9 is 3 and 3. We have same signs, and both are positive. From there, we want to set each factor equal to 0. Now, this is the first time that this has come up where our greatest common factor has just been a number. Do I have to set this equal to 0? And the answer is no. It's just a 2. 2 is just 2. It's not going to be 0. So really, we only care about anything that has x's in it. Just like on the last problem, I only have to do this once, since it is a repeated factor. So I'm just going to set x plus 3 equal to 0. I can subtract 3 from both sides, and we get x equals -3. That is our one solution. All right, last one. 9y squared minus 25. This has only 2 terms, which tells me difference of squares. So if we go ahead and factor this, 9 is 3 and 3. Y squared is y and y. 25 is 5 and 5. And we have different signs. Now for this, do I have to set both factors equal to 0? The answer is yes. They are not the same, they are different. So we do have to work with 2 equations. So I'm going to set 3y minus 5 equals 0. I'm also going to set 3y plus 5 equal to 0. So on each one of these, see the first one, we can add 5 to both sides. We get 3y equals 5. And then I can divide by 3. So we get y equals 5/3. For the second equation, I can subtract 5 from both sides. I get 3y equals -5. And then I can divide by 3. I get y equals -5/3. So if you want, you can put them in squiggly brackets. We get 5/3, comma, -5/3. And that takes care of our solving equations. That takes care of this section. We have one more section to finish off this module. The last thing that we're going to talk about is our polynomial functions. So go ahead, take a break, and I'll see you again shortly.